So I'm Ian. He was going to introduce me. Some of you know me. That's really awesome. Thanks for coming. And yeah, I work at PowerDMS downtown here in Orlando. So if you want to find out about moving to Orlando and working here, hit me up. It'd be awesome. The talk today is going to be about Kotlin Multiplatform. And the goal of this talk is to try to give you enough information that you can decide if you want to look into using it in your business. And if you do, you should have hopefully enough information to make a good argument to your coworkers about why you should consider it at least. So that aside, what is Kotlin? General purpose programming language with static typing and type inference. That's boring. Does anybody here know what that means? No? Okay. Neither do I. So multi-platform, the meat of the talk. So multi-platform is probably a new term to most of you guys. Is anybody familiar with multi-platform before Kotlin made it a trending term? No? It's got a few head nods. That's pretty good. I'm going to thank Kevin Galligan for this. He defines multi-platform, specifically with Kotlin, as optional, natively integrated, open source, code-sharing platform based on the popular modern language Kotlin, facilitates non-UI logic availability on many platforms. Again, that's a really rough definition. I'm not much of a words guy, so I'm going to use my own definition. So multi-platform, you just compile for the target platform. Everybody understands that one, right? So I have a language, and I just want it to run on something. So let's do that. But the other term that you've probably heard a lot is cross-platform. And cross-platform is quite a bit different, even though in many ways they share some of the same goals. With cross-platform, you want to write code and you want to run it on the device. However, there's usually something in between the device and what your code is doing. So if you think about Java, you have a JVM. The JVM is acting as like the cross-platform facilitator. You don't really care what JVM or what the JVM is running on. You just care that your code does a certain thing. So that would be like a cross-platform, where multi-platform would be like compiling your C code for a specific architecture, or running JavaScript in the browser was meant to be run, things like that. All right, so the cross-platform landscape. Just give you guys a minute with this one. That's gonna be a little bit. Still going. So there's probably some takeaways here. There's a few people that have tried to do cross-platform before. And that's an important thing to consider. Why would so many people build their own implementation of what is arguably in many ways the exact same thing? They just added their own meat and potatoes to it. When we look at the landscape, you're probably familiar with these three, and the rest of them, maybe you saw it once, maybe you used it once, but these are the three that have basically survived and are what everybody considers as the options today, outside of some very specific use case ones. So we've got Flutter. There's gonna be some really good Flutter talks later today if you wanna check that out. React Native, I hope everybody's familiar with that one. And of course, Xamarin. Hi, Microsoft. So multi-platform, it's all around us. Every one of you is using multi-platform today in your everyday life. Your phone is running it with Linux. There's an asterisk on the number of architectures. I pulled it off the Wikipedia page. At any given point in time, this is how many architectures it supported, but not necessarily all at once, so don't quote that. Game engines. Everybody's played a video game. Consoles, desktops, your laptop, your phone, even web browsers now, they have game engines that compile for all of them. And they do it by compiling directly for the target platform, sometimes in a cross-platform way, depending on the target. Like web, I believe, is usually with some kind of intermediary. But write code once, run it everywhere for the most part. All right, and your browser. Your browser is probably the most common one. Like, they didn't make Chrome 5 times. They just made it once and tweaked it a little bit for the UI that they needed on every platform, which is really what Kotlin Multiplatform is all about, right? So why do all these choices exist? Anybody? What are you doing? No? Some shortcomings between them. That's pretty good. That's probably definitely a good answer. I would argue that it's money. Developers are expensive, right? People, just in general, are expensive. The more people you have, the more expenses you have, just flat. Doesn't matter what country you're in, doesn't matter what you do, people are expensive. And if you're in the United States, depending on which data source you use, you're gonna see something like $90,000 a year is the average. It's gonna vary by what skill sets you have and which industry, sure, but 90,000 is a good, nice round number. So you can imagine that if you can cut out even one developer on your project and still get to completion, that's a big win. You can spend $90,000 elsewhere on advertising, hardware, whatever else you need as a company. So when you think about these solutions like cross-platform and multi-platform, at the heart, that's really what they're trying to solve, get more done with less resources. And of course, building software is difficult. Again, this is just like looking online, trying to pull some numbers, 4 to 12 months on average to complete an idea from idea to the end goal, like initial release, right? And then of course, everybody knows this one. No project's ever done on time. It's never happened. If you think that it happened, you're probably wrong about it. It's always late, right? So around the world, there's some pretty interesting stats. We spend north of $125 trillion every year developing software as the global economy. And I believe this was from like 2016, so it's probably a lot higher now. We have 23 million developers, and by 2023, we're gonna have 27.7 million developers. So that's a lot of people to pay. And another just really interesting bit that I found was that 60% of people consider themselves backend. And again, when you're talking about compiling to multiple targets and not worrying about the UI so much, that's a pretty cool stat. All right, so hopefully you agree with me that cross-platform and multi-platform can save time, and thus money, and hopefully complexity. All right, so elements of a software stack. There's a lot of answers to this question. You'll see answers somewhere between like 3 to like 12 pieces of what makes up a software stack. I look at it as like 3 main pieces. The first one, we've got the platform, right? What is this thing that you're building meant to run on? Are you trying to target a phone? Are you trying to target the web browser? Are you trying to target a game platform like a console? That would be the platform to me. So when we think about Kotlin Multiplatform, we have to understand that it comes with certain restrictions. It obviously doesn't run on everything ever made. But it could if you put in the effort for it. So the first one that everybody knows is that it runs on the JVM. It compiles to a Java bytecode, and everybody's happy there. We're all using it on our phones. A lot of apps have switched, right? JavaScript. This is a little less known, but you can actually write Kotlin for JavaScript. Even better, you can write Kotlin for JavaScript that works with Node, and then you can write Kotlin for JavaScript for front end and back end, and we can all call ourselves full stack developers. Finally, we did it. Of course, iOS is the other one. That's probably what most of you guys here are interested in, between JVM and iOS. macOS. This one is kind of like iOS, but it's my understanding it's a little bit different. There should probably be an asterisk on this one. Don't expect it to work for you yet. Same thing with ARM 32 and 64. If you're targeting Android ARM 32 and 64, you're probably going to have a good experience. If you're targeting something else, it depends on the device. Like iOS, I believe, is well supported, but one of the examples is that they say that you can get a ARM development board and make a blinky light with an LED like an Arduino, right? Not really. If you try to do that with a project example, it's not going to work for you. But it's something I'm sure that they're going to get to eventually. So asterisk for that, make sure you check into it. Same thing with MinGW. You can. It technically works. Somebody got it working. So you're going to find support lacking, though, probably. And then WebAssembly is the new one, which I expect will probably be one of their next big focuses. Because that is going to be really powerful, getting native performance code into the web browser and sharing it all the way up the stack. So when you build for Kotlin, you take your Kotlin code, which is called common code, because it's not associated to anything, right? It's not like when you're writing Java, Java's for the JVM. Kotlin is its own language, and without understanding a target, it really isn't anything. You've just written like words into files. With a target, however, you are able to bring in extra features and understand more about what you're trying to do with the code and what the code is capable of doing as features become available and disappear in Kotlin based on the targets. So you have the common code, and we have a compiler, and the compiler is going to spit out the target-specific code. And that might be a binary, that might be, like in JavaScript's case, you're going to have just pure JS as a file. And other things like the JVM, of course, is going to spit out bytecode. So the output is very unrelated to the input, and it really just depends on that middle piece. So if you can write the middle piece, you could technically support anything, much like with LLVM, which is something that Kotlin uses partially, and just that kind of approach. So the next piece, we've got tooling. Now, tooling is, in my opinion, the most important. Tooling provides everything that you need to ensure a quality product. If your tooling is bad, your product has a good chance of also being bad. Not that good tooling makes good products, but they help. Everybody here is probably using an IDE. If you were trying to write Android with like a text editor, I'm impressed, come talk to me. I want to find out about how you do that. I know some people use Vim and things like that, which is pretty crazy. But tooling really helps connect all the dots, with the IntelliSense and is this code even good? Did I make a silly mistake? Did I forget to initialize something? Tooling connects all those dots for us. And without that, I wouldn't want to use the language. So IDE choices. Everybody's familiar with this one. We've got IntelliJ. IntelliJ is the most Kotlin enabled of the IDEs. It's always at like the leading edge, right? Followed closely by Android Studio. Some of the other JetBrains IDEs also support Kotlin. It's all just part of the plugin module, but you'll find that these two are probably the best supported just because of the money that's behind them at all times. And then, of course, Eclipse. I don't know why you would do that, but that's an option, so that's pretty cool. And then you have the shell. So like if you're just one of those people, you just want to write text files, I mean, like you can do that. They enable you to do that, and that's power to you, right? All right, documentation. If you don't have documentation, the next person that works in your job is not going to like you. So without documentation, you also probably don't want to use that tool, right? Thankfully, Kotlin has Doka. And Doka allows you to build out different documentation styles. This is the Kotlin version of documentation. However, you can also print out JavaDoc. You can print out like GitHub compliant Markdown. You can do another form of Markdown and a few others. And just like Kotlin itself, if there's a different format that you need, like they have a way to facilitate building out your own custom documentation. For instance, the Kotlin website is generated partially by Doka. So they're literally dogfooding this tool, and it's quite powerful. The next one is detect. With static analysis, you can really step up your code quality. Again, not necessarily good code, but it'll pass the analysis, right? Detect does a lot of work. It has, I believe, like several hundred checks at this point. It runs in, I mean, on this one, you can see it ran in about a second, and you can check massive projects. The project that I work on every day is about, I think, 30-something thousand lines of code, and detect runs in about 2 seconds. So this is almost like a free, of course, we run the tool, because it's just, why wouldn't you, right? And as you can see, it breaks everything down, and this is all inside of a CLI, which is fine, but it also prints out a nice HTML report or XML if you want it. So whatever your flow is, just like Doka, you can get that out of your tools. So that's tooling. And then ecosystem. Now, ecosystem is the empowering part of like acceleration, right? Without ecosystem, it's going to be really hard to complete what you're trying to do. Be that libraries, be that like blog posts that teach you how to do something, be that the resources from the language owner, so from like JetBrains themselves. Ecosystem all wraps up into that. And one really awesome thing about JetBrains is the way that they've done their education of Kotlin. You really don't need to pay anybody to teach you Kotlin. You can go right to their site. You can write code right in the web browser, run it right in the web browser. You don't need to install anything, and you can learn everything you need to know about Kotlin right there. Once you want to jump into like multi-platform and Kotlin native, of course, you're going to have to get tools and stuff like that. But just the learning experience, you don't need to go anywhere. You don't need to get a book recommendation, and you don't have to go watch like 8 hours of YouTube videos to get caught up. Like you can just hit the road running. So from the point of multi-platform, the ecosystem is going to be Maven, which is the same thing that Java uses. So that's awesome for all of us because we all already understand Maven, right? We also all understand the elephant, Gradle. And with Gradle and Maven, you can deploy your artifacts, and JetBrains actually put in a lot of work making sure that the multi-platform plugin directly supports Maven publishing. So if you've ever had to do something like try to publish an Android library to Maven, this experience won't make you sad at the end. Like it actually works, and it works really easily. There's a few gotchas, but it's easy to get through. And now there's several projects doing it, so there's easy templates to follow, and it's all much, much smoother than what you may have been used to in the past if you've only done it from an Android perspective. All right, so once you deploy a multi-platform module, and we're gonna circle back on this a little bit, so you have a version inside of Maven, right? And you have artifacts. So these are the artifacts that I've deployed for a project called Arbor. If anybody's familiar with the project Timber by Jake Wharton, it's a logging library, so I made Arbor because he doesn't technically have a multi-platform version. He kind of does. It's just not really released yet. So I took an attempt at basically taking his API and just making it a multi-platform project. So we can see an interesting thing here is that I can depend on Android, JS, or the JVM. So obviously in an Android context, I want the Android one, but if I'm working on a JS project, I can take that one or the JVM one, and these are all packaged the same way that you would expect them to be if they were just a Java module. Next, we have these two other ones that are named completely different. And this is actually part of the infrastructure of Kotlin Multiplatform when you share it. So common metadata and common are both like container modules, and they describe the other modules that are available as part of this complete package. Now that's really valuable down the road because you'll be able to start describing dependencies generically. You'll be able to say, I just want Arbor and this version of it. Whereas today, you kind of have to go in and say, I want Arbor, but the Android one and this version of it, which isn't that big of a deal. And technically it works today to say generically, but I haven't been able to make it work on my machine, so maybe it does. Other people claim it does. So when you look at the packages, if you were to break them down, it's effectively that common and the common metadata. The key piece there is a JSON file. And that's the actual multi-platform module, and that describes the other three modules that we have inside of the repository. So JS, JVM, Android. And the experimental part is the metadata that brings in Gradle information and a few other things. But like I said, I haven't been able to get that to work, so who knows? So this is really what it looks like. So if you can imagine what your Maven dependencies look like right now, this is the only thing that got added effectively. It's just a quick little file. It describes a few things about your project. This is describing the Gradle version that the project was built with a little ID so that it can be quickly checked. That's really important for compatibility reasons. And going forward, hopefully that just becomes something less important. But next we have the variants, and this is just the array. So this is the pointers to all of those individual modules. And this is what Gradle is going to read when it goes and grabs dependencies for you, in the future anyways. So continuing the ecosystem talk, projects available today. You might not be aware, but there's quite a few. KTOR is a really popular one. That's for networking. And you can use that on, I believe, almost all of the platform targets that Kotlin supports in various manners. Some of them are a little feature lacking, like Linux right now, where others are really feature complete, like the JVM. But I believe even iOS and Android have fairly good support at this point for the client and the server side. So if you're trying to go that route with a project, it might be something to look into. And they also support, the next one inside of KTOR is coroutines. So with coroutines, you can get really lightweight threading, asynchronous code, and you can extend that out into your projects and think of it as like replacement partially for things like RxJava, although Kotlin does have a reactive library coming up in the future. So Kotlin.io is a serialization library. So if you want to serialize JSON, KBOR or CBOR, I guess is the name, also protobuf and a few others, this can facilitate that. Again, it comes with some gotchas. If you're used to using JSON or Jackson, there's some things about this that might kind of throw you off, but it does work. It works pretty well, and it's pretty performant. Yeah. So he asked if this would be a replacement for Moshi. In a sense, yeah. Moshi does compile time, like linking, right, of the models. For the, is that correct? Yeah, it generates the type adapters for you. Yeah, so Kotlin IO works the same way. You put some annotations on your models, and it'll generate Kotlin code for you. One really specific difference is that it does it with the compiler. So like when you change an annotation and hit refresh, it's done. Like there's none of the like, okay, go get a coffee because you have 40,000 models and this is going to take a long time. I found that really refreshing and pretty cool when I was trying it. However, again, I can't stress that it does come with some minor caveats, so try it out before you go all in. Or sorry, that was the serialization. IO is the underlying networking part. And then atomic foo. Kotlin Common doesn't have atomics, which is kind of a problem. So there's some attempts to try to come up with an idea for how atomic should work in a multi-platform environment where not every target platform will understand what an atomic is or have an atomic available already. So that's all on the Kotlin side. On the community side, SQL Delight is a way to do cross-platform SQL. And it works on Android, it works on iOS, and I believe they were making it work on the web, or they were investigating it. Multi-platform settings. So this one is for iOS and Android specifically. So if you're looking to try to build a project for both of those, you can use this, and it'll sanely use both settings systems. And it comes with like some limitations on how to make that work, but it actually works pretty well. I encourage you to look at that one. Stately is a good way for kind of a state machine approach. And then OKIO is actually a rewrite of the original OKIO for multi-platform. I'm not sure what the status is of that one. Then Timber, we talked about that. Don't use Timber yet. It's the 5.0 branch. I assume it's going to get finished soon because they started, I think, like 9 months ago. So it'll probably be soon that they decide to release it as multi-platform is finally caught up to some level of stability. And then, of course, I mentioned my library. So if you want Timber, you can actually just use Arbor, and you can use package renaming to rename it until Jake Wharton releases his, and then I wouldn't blame if you got rid of mine. That's fine. No hard feelings. And then another library of mine is Kfin State Machine. So if you are interested in state machines, I support multi-platform with mine, again, to an extent, but it seems to work pretty well. I just need to play with it some more to see how useful it is everywhere. And I want to throw out thanks to TouchLab for that previous slide, because that's mostly their slide. If you want to see an example of multi-platform in the wild, they actually built the DroidCon app in a multi-platform manner. So the app is iOS and Android for both. You can check that out on the repository. It's really, really interesting. I totally recommend that you guys check it out. It's got a lot of new concepts, like using coroutines, no RX, so that's going to be set back, like reading it for you. And then, of course, having that iOS module there gives you a lot to take in and consider. So if you wanted to get started today building a multi-platform library, it's really easy as long as IntelliJ was your IDE choice. So all you have to do is go to IntelliJ, new project, and it's already there. Like, you already have it. So if you have IntelliJ, congratulations. You can start a project literally right now. It'll take you about like 30 seconds to set it up. And once you click that build button, you'll have a directory that looks like this. The last two say Linux. On your machine, they're probably going to say OS X or Windows. But we can see right here we have Common, JS, JVM, and Linux as source directories. Otherwise, this project looks pretty similar to any other IntelliJ Gradle-based project that you've seen before. So there are all the modules. You can see all the names, and you can see every single one, or every single target has a test module associated to it. right out of the box, so no configuration there. And this is what the entire configuration looks like for the project. So when I told you that this was easy, like you can literally just do Maven publish on this, well, publish to Maven local, and it will build the library for you and put it on your local system. If you want to deploy to OSS or something like that, obviously there's a little bit more work, but like right out of the box, it just works, which is awesome because that's not the experience that you get coming from Android. So diving into a little bit, we have targets, and targets are how you define what you're going to compile Kotlin to, right? So in this case, JVM, JS, Linux, pretty simple. And then we configure the source sets of the project. So the common is the foundation of the project, and everything's going to build on top of that by depending on it. And that dependency is a given. So what I mean by that is you can actually create other source sets that only certain source sets depend on, whereas this one, all source sets depend on it. And so you can see here with JVM main, JVM test, those actually already depend on common for you. So if you go to build this, it's going to pull in any code in common and make that as part of the actual application or library. So when you build this new project, this is all the Kotlin that you're going to have inside the common main package. And you see some new words here called like expect. And this is just a class and an object demonstration, but you can also do values. So if you need to expect a variable or an immutable val, like you can do that as well. So we have a sample and the platform, and we're expecting all of the targets to implement these for us so that they can compile. And over here on the sidebar, we have a new little icon. It's like a little row of A's. And it might look weird because you're like, well, it says expect, why does it say A next to it? So if you click that, it'll actually show you all of the actual implementations inside the project. And this is what an actual implementation looks like. So this is the sample.js file, and this is Kotlin that's going to be compiled to JS, and we see a lot of the same stuff. Instead of expect, it's actual, because this is the real implementation. Same thing with the object. And over on the sidebar, we see E's. And now it makes sense. The E's connect back to the expect implementation, A's connect back, and it makes it really easy to jump around inside the project when you start having multiple target platforms. All right, so issues. Obviously, not everything works smoothly with this. Code coverage. I don't have a really good answer for this. If you want to code coverage the common module, that's not really a thing. You need the target platform to code coverage that, which then gets a little weird when you have like 4 of them, and what's your coverage when you're covering part of it like 4 times? It's just a little strange. Basically, you're going to want to use something like CodeCov, or you're going to want to use like Sonar Cloud if you can figure out the documentation for that, and have them bring it all back together for you. And from my experience, that worked pretty well so far. I haven't hit any big snags. So if you have that as an important requirement in your business, you're gonna want to look into that and probably use a third-party tool. Depends on. I found out that that's a little bit of a trap. Depends on is where you create a module that gets shared with other modules for the targets. So if you think about a JVM module, you might have just a plain Java implementation of something, and when you go to build your Android module, you have your custom Android code, but then you realize I don't really want to copy the class into my Android implementation, so I'm just going to make my Android module depend on the JVM model. That's great for an application, but for a library, what that means is that when Android goes to depend on that, it'll end up depending on the JVM module and the Android module, which means you have duplicated classes inside when it goes to compile. So same class, exact same class, same package, and then you have to go add nasty excludes on your dependencies to get rid of that. And I don't know why that's the case, and I have a feeling it's because I did something wrong, but it's something to be aware of. The next one is public knowledge. I'm trying to do my part and share some, but you're going to find that it's sparse. The 1.3 release just came out a few weeks ago, so if you're looking for lots of good quality information, it might be a little tough to find it right now. I would recommend just trying to triage GitHub for apps such as that DroidCon one. That's a really good place to start. But if you're looking for lots of other samples and guides, maybe wait another quarter or so. All right, IntelliJ. Surprisingly enough, IntelliJ is actually one of the problems. I frequently, when doing multi-platform, have IntelliJ just lock up. It usually recovers, but it just kind of sits there with a spinny, and sometimes it's 30 seconds, sometimes it's 3 minutes. It doesn't seem to matter what computer I'm on, so you're probably going to experience some stuff like that. Of course, with anything new, you're going to have a lot of that going on, so just expect it. The other thing with IntelliJ is that I've run into a lot of situations where I can't figure out what's wrong. It's complaining about something, and for whatever reason, just re-importing the project fixes it. It's really frustrating when you waste a bunch of time trying to debug a problem, and then you find out that the IDE was just broken. So look out for that and know that it's not just you. And then, of course, downstream compilation times. If any of you guys are using Kotlin on a larger project, you've probably experienced this. Kotlin is not the world's fastest compiled language, at least to the JVM. And to the other target platforms, you're going to experience that as well. It is not going to be the world's fastest thing to compile. All right, so the black screen means that it's demo time. Okay, so I built a multi-platform project to share with you guys. I'm not sure why Android is empty over here, but so I built a calculator in multi-platform. It's on GitHub, so you guys can go find it today. And there we go. Okay, so obviously Android on the left. This is a web browser. It's served up by Node, Node.js, and then this is a Swing app because I know Swing is really important to a lot of people still. So we can use the calculator. All right, it works, and we get exactly what you would expect, right? Let's see if we know. There we go. Okay, so I was able to build this all with one class implementation inside the common code, compile it for all the platforms, and then write platform-specific UI implementations. So if you look at Android, obviously it looks a little bit different. With Swing, I could not figure out how to get the sizing right here, so it looks a little silly. And then, of course, JavaScript, this is all just plain HTML, and even a little bit of JavaScript on that side. And they all just connect back to that class that I wrote, and that got compiled for every native platform. All right, so this is what that class looks like. Let me do. That worked perfectly. There we go. All right. So this is just a regular Kotlin class. It takes in some inputs. You can see that I actually have Arbor in there. So you can see an example of taking a multi-platform library and bringing it into a multi-platform application. If we look at, I guess I'm running low on time there. Oh. Does anybody know the hotkey to get out of? Yeah, I can't think of the name. It's all right. Running low on time. All right, so the next thing to get back to, so that was like a working multi-platform application. It's on my GitHub. I'll give you guys a link for that a little bit later. The next thing is seeing some of the tools working, which bear with me because the monitor is like a little bit smaller. All right, so here we have a detect report, right? So this is everything in your project looks good. It's just giving you some information about it. So if I was to come in here and write some bad code, let's just hit a line length. So this is something everybody does every day, I'm sure. And we're going to run detect real quick. So detect is going to fail because I just failed like a quality control, right? So here is an example of what that kind of reporting is going to look like. And so if you can imagine your CI doing this for you, this is going to go real smoothly and just give you instant feedback. And like I was saying, completed in 1 second, so pretty good, pretty low cost there. Well, now I need to change what I want to run. No. Crap. All right, well, I want to change what I want to run, but all the everything's gone. Oh, is it still in presentation mode? There it is. Now it all makes sense. All right, so the next one was Doka, and just like I was saying, you can get some, you can get documentation. So again, runs quite fast as long as you don't do Java doc. So if we want to see an example of that, we can come in here and just do something like hello DevFest. rebuild that. Go check out Arbor. And tag. And we can see hello DevFest. So almost instantaneous, and the logging is kind of nice. It has like a root package, so you can see all the types and everything. And if you really want JavaDoc, you can do that, or you can compile for GitHub. And then let's see. Yeah, so that was pretty much the end of it. If you're looking for like the implementation details of how to do it, please check out my GitHub. It's just Toxic Bakery. I probably should have put that on the slide. But yeah, come talk to me. Does anybody have any questions that they want to ask out loud? Is that one? Did you have one? No? Oh, okay. So,